You know, I recorded this entire video, and it wasn't recording. So we're gonna get into this. I'm probably not gonna explain it as well as I did, but oh, I feel like an idiot. Anyways, it is now 11 o'clock. I started recording this 30 minutes ago, so we're getting back into it, starting from the top. We're doing, it's another day, another LeetCode problem. We're doing problem 168, Excel sheet column tile. Given an integer column number, return its corresponding column title as it appears in the Excel sheet. So for numbers 1 through 26, we return A through Z, and then 27, 28, we would do A and then the corresponding value after that. So it was kind of apparent to me that they're wanting us to count in base 26 number format. So like if you don't know much about base systems, we count in a base 10 system, and then like computers count in a base 2 system. That's what binary is, zeros and ones. There's only two digits to represent each value place. So like the zeros place, the tenths place, and so on and so forth. And then there's hexadecimal, and then the hexadecimal, and then 16, the base 16 system. So all those are useful for computers because a hexadecimal and the 16-bit is just a byte. I mean, a byte of base 2 is just one single value in hex. So that's also, I mean, that's very useful if you know for reading. Binary is you're able to consolidate it down into hexadecimal, and then so on and so forth. So what we did for this problem is we know we want a string, so I just called this solution, set this equal to this. I also mentioned that if you know how to use the string builder, it's probably better to use the string builder class, because then you're not creating and deleting a string object. The reason you would want to use the string builder is because strings in Java are immutable. That means you can't change the object specifically like you could an integer. They could add one to an integer and then it stores the value back into the solution without creating a new object and deleting it. So every time you manipulate a string in Java and you store it back into the string reference object, you're not actually changing the original string you created. You're creating a brand new string, and you're setting your reference object to that new string each time. So that's what we're doing every time in the while loop. So we want to do the column number while it's greater than 0. We want to be sure to increment the column number by 1. The reason we do that is because given 1 through 26, we want to put it in a range from 0 to 26. And then when we do that, we can go ahead and do get the remainder, and that will be our first, that would be our index value, or our what's it called? Our character value. This will give us our character value for the current digits place, or like letter place, I guess you would call. And then if the remainder will be in a range from 0 to 25, which is what we want, instead of 0 to 26, because the 26 wouldn't give us a value, right? It would give us the 0 value, and then if the mod by 26 gives us 0, then we want to, without decrementing first, we want that to be Z instead of A, but it's just easier if you decrement it by once and then you get the range 0 from 25. It's just a lot easier that way. So then we want the column number to be, or the remainder to be equal to column number mod 26. And then we want column number to divide equals. We're using the division assignment operator. And then we want to divide that by 26 and store that each time. And then we want our solution. This is where we actually store the value. We want to cast this addition as a remainder. So if you didn't know, I went over this briefly. I'm not going to go over it as in detail. Oh, flashbang. No, characters are stored in number values, and then because they're labeled as a character, that's when they get outputted an actual value. So the value 65, when it's stored as a character, is the value a. And then a goes all the way to z in incrementing order. So z is 25 plus a, so that would be 90. So 65 plus 25 would be 90. And if we do 0 plus 65, that would give us a. And if we gave like 3 plus 65, that would give us 68, which is what we want, because that would be the fourth letter in the alphabet. Because 0 is a, so if we're given a 0, that would be the first letter in the alphabet. And if we're given a 3, we want the fourth letter in the alphabet, and that would be D. So that's kind of what we're wanting to do here. So we're going to just add the remainder to the character value of a. And this would give us the character value for each pass. And then we add that character value to our solution. And this would be sure to loop over each character value. If the column number is greater than 0 in the second pass, then it knows we need a second character in front of the first character we stored, and so on and so forth if the value is very big or very small. Like in example 3, 701, if you mod that by 20, or you subtract 1 to it, you would get 700. You mod that by 26, you get the value 24. 24 plus 65 gives you 89. And we look at the ASCII table. 89 gives you the value of y, which is what we want, y. And then we go ahead and store y into our solution. And then you go ahead and store the column number divided by 26. And that gives you the value 26, because the remainder was 25. And then this is integer division. So if you divide that by 26, 26 goes into 700 26 times. And then since column number is greater than 0, we go ahead and do this block of code again. So column number is now 26 for the second pass. You decrement that by 1, you get 25. You store the remainder, so column number mod 26 gives you the remainder of 25. Column number divided by 26, when it's 25, will give you 0, because you can't divide 26 into 25 any times. And so that will be sure that we break out of the loop for that occurrence. And then we go ahead and find the character at remainder. So 25 plus a, which we know is 65, gives us 90. And 90 is the character value for z. So it stores the value z plus our previous solution. So we're building our solution as we go for each iteration. And it goes ahead and returns our solution. So we go ahead and submit this. It runs in 3 milliseconds. I think that might be a little bit from the overhead of creating and deleting objects. I'm not really for sure. I'm thinking that would be the case. If you use the string builder, it'll probably be a little bit faster, because you're not creating a string object each time and storing it. But anyways, that's gonna be all for today's video. I made this one a bit quicker because I spent 20 minutes on the last video. Not the last video, the recording I did of this before, but I didn't click record. So, I mean, you can't post anything you didn't record. So I went ahead and redid it really quick because I've got stuff to do and I want to get in bed. But anyway, that's gonna be all for today. Y'all stay coding, y'all stay blessed, stay healthy, and I'll catch you on the next video. Hey Devs is out.